Okay, today we're going to be reviewing some solving systems of inequalities, and I'm going to work a few of these problems from your practice assignment with you. And basically, one thing you're going to be doing on this page that we haven't done before is I have asked you to do each of these by substitution or elimination, but you can check your work by graphing. We'll go through that. When you're choosing between substitution and elimination, I want you to kind of use this guideline. If at least one equations or maybe both equations are solved for a variable, substitution is probably the best way to go. If both equations are in standard form, elimination is probably the best way to go. So if I'm looking at number one, I see both of those equations are solved for y. So the best way to go there is probably just to do to do a 3x minus 7 equals a 3x plus 4. And I have equations here I can solve. Now on this one, I need to solve for y, I need to get all the variables on one side. So to move a positive 3x, I'll subtract 3x. And what you'll notice here is that all the variables go away. And at first this might panic you, but this is going to happen a lot on this assignment, because the other thing we're doing, in addition to reviewing substitution and elimination, is we're looking at problems where they're kind of special cases. So in this one, since your variables cancel out and you get a false statement, we have talked about it in class, and it was on your review notes for today, that if your variables go away and you get a false statement, that means there is no solution. What has basically happened is these are probably parallel lines that do not have an intersection, so there is no solution. So what your answer would be for this one is you would just write no solution for number one, and you've shown your work, and you've written no solution, and you would get credit. Now, if you want to be more confident about your answer, I'll show you how you can check it with Desmos. And what you do in Desmos is you just type in both the equations exactly as they were given to you. So y equals 3x minus 7, I believe, and y equals 3x plus 4. Just type in both equations exactly as is, and you will see that these are parallel lines that never intersect. And the point where the solution point is the point where these lines intersect. Since these lines don't intersect, this is no solution. So hopefully that will help you on that one. I'm going to go ahead and try number 3 if we have time. On number 3, both of these, neither equation solve for a variable. They're both in standard form, so that's the perfect time for elimination. So I'm going to go ahead and add these equations together. You would not want to add them together unless a variable would cancel out, but it looks like the x's will cancel out. So when I add these up, the x's cancel and the y's cancel. So I basically have nothing left on this side. It's just a 0. And on this side, 10 plus negative 10 is 0. So I get a true statement, 0 equals 0. This is another special case, but since this time the variables cancel and I get a true statement, this is infinitely many solutions. So you've shown your work, you're writing infinitely many solutions, so that's what's going to get you credit for today's assignment. But once again, if you want to be more confident in your answer, we can go to Desmos. So we'll go back over to Desmos. And I had 2x minus 3y is 10. And I had negative 2x plus 3y is 10. Now, is negative 10. Now, what you might notice is that the second equation goes right on top of the first equation. If you're not sure about if that happened or not, you can always just click this purple button in front, and that will toggle that on and off. So you can see that that purple line is exactly the same as the green line. What this means is any point on this purple/green line is a solution. So this point here is a solution. This point here at 2, negative 2 is a solution. This point here at 5, 0 is a solution. I've got another solution at 8, 2. There's so many solutions I can't list them all. That's what infinitely many solutions means. But algebraically, if it cancels out, the variables cancel out and it's a false statement, it's no solution. If the variables cancel out and it's a true statement, often but not always, it'll be 0 equals 0. That's infinitely many solutions. Hopefully this will help you get a good start on this assignment.